Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Rhivo Aprianto, and I will tell you about branch and bound algorithm. And the first one, branch and bound is a powerful technique for solving optimization problems, particularly those involving combinatorial decisions. It works by systematically exploring all possible solutions, but it cleverly uses bounding function to prune out branch and that cannot possibly consent the optimal solution. This makes it much more efficient than simply trying every single possibility. Here how it works. Divide and conquer. The problem is first broken down into smaller subproblems. This is often done by making choice each step by step, such as whether to include a particular item in knapsack or not. Bounding function. For each subproblem, bounding function is calculate. This function estimates the best possible value, e.g. minimum cost and maximum profit, that could be achieved by any solution within that subproblem. Pruning if the bound for a subproblem is worse than the current best solution so far, then there is no need to explore that subproblem any further. It can be safely pruned from the search tree. And exploration. The algorithm continues to explore the most promising subproblems. Based on their bounds, this typically involves choosing the subproblem with the tightest bound, the one that is close to the current best solution. Convergence. Eventually, the algorithm will explore all the remaining subproblems and find the optimal solution. Here's an analogy to help illustrate the concept. Imagine you are lost in the maze and trying to find the exit. Branch and bound would be like trying all the different paths, but with a special ability for each path, you can estimate how close it is to the exit without actually going all the way down. If a path is definitely farther than the best path you've already found, you can skip it and try a different one. This saves you a lot of time and effort compared to simply trying every single path. Branch and bound is a powerful and versatile technique that can be applied to a wide range of problems. Some common examples include knapsack problems, deciding which items to pack in a knapsack with limited capacity to maximize total value, and traveling salesman problem, finding the shortest possible route that visit a set of cities once and returns to the starting points. Job scheduling problems, assigning jobs to machines in a factory to minimize the total completion time. Bin packing problem, paying items to bins of limited capacity to minimize the number of bins used. Branch and bound is not always the fastest way to solve a problem, especially for every large problem. However, it can be very effective technique for finding the optimal solution, even for complex problem with many possible solutions. Deeper dive into specifics. Different types of bounding function. There are various ways to calculate bounds depending on the problem. We can explore example of linear programming, Lagrangian relation, and other bounding techniques. Algorithm implementation. Different start strategies exist for exploring the search tree, like depth first search of best bound for search. We can discuss the pros and the cons of each approach. Complex complexity analysis. Understanding the time and space complexity of branch and bound algorithms can help access their suitability for particular problems. Application beyond combinatorial problem. While classic application lie in discrete optimization, branch and bound can also be adapted to continuous optimization problems with certain structure. Additional aspect to consider. Parallelization, exploiting the potential of parallel computing and can significantly speed up branch and bound algorithms. Hybrid approach, combining branch and bound with other optimization techniques like meta-heuristics can sometimes lead to even better results. Challenge and limitation. No algorithm is perfect, and branch and bound also faces certain limitation in specific problem scenarios. We can discuss potential drawbacks and alternative strategies. Conclusion: finding the optimal solution. This is the ultimate goal, the reason we embark on the entire exploration of the search tree. When the algorithm eventually stops having assignment all promising branch and prune the rest, it presents the gold medal solution, the one that minimizes the cost, maximizes the profit, or fulfills the objective's function in the best possible way. Understanding the solution space, the journey to the tree doesn't just deliver the final answer. It also reveals valuable insight about the entire landscape of possible solutions. The bounds calculated at each node see light on the range of potential outcomes, providing information about near optimal solutions and identifying areas where improvement are unlikely, guaranteeing optimally. Unlike some heuristic algorithm that approximate solution branch and bound offers a guarantee by systematically exploring all valid paths. It leaves no stone unturned, ensuring the solution it reports is truly the best possible given the constraints. An objective function. This certainly can be crucial in high stakes decision making scenarios, efficiency and limitation. The conclusion also tells us something about the algorithm performance depending on the complexity of the problem and the effectiveness of the bounding function. The path to the optimal solution might be fast and direct, or it could involve traversing a significant portion of the search tree. Analyzing the number of explore nodes and the time taken helps assess the efficiency of the algorithm for specific problems instance. And I think it's enough. Thanks for watching. Wassalamualaikum warahmatullahi wabarakatuh.